Okay, so I'm going to drop off here. Let me introduce our speaker first. This is Tom Swartz. Tom is a longtime presenter for CPOSC. Today's topic is surfing radio waves with PostgreSQL, which I'm very interested to see what he's talking about. Tom's a developer support specialist for a company called Crunchy Data, programming software for and around Postgres databases. And he's also an avid speaker. Like I said, been in many Central Pennsylvania open source conferences, Tech Lancaster events, and other events around Central PA. He's an avid enthusiast of mechanical keyboards, amateur radio, and a passionate advocate for free and open source software. So with that, I'm going to bow out, and Tom, the stage is yours.
Thank you very much, Jay. So, I'm Tom Swartz, and today we're going to be talking about creating sample data sets for Postgres for fun and profit. And we're going to be kind of talking about all kinds of different methods for generating those data sets. So I like to do a little bit of an introduction. Who is this handsome gentleman that's speaking before you? I have 5 years DBA experience, support experience. I work for a company called Crunchy Data. And this specific topic that we're going to be talking about today is kind of like the perfect intersection between what I do for a day job and kind of my hobbies on the side. So a lot of my hobbies are RF communications, Internet of Things, big data, all kinds of really nerdy stuff. And this topic kind of is the perfect intersection between all of those things and actually doing stuff with databases. So hopefully you'll find it enjoyable. So the first question you may have when we're talking about creating sample data sets may be why. Why would I be interested in setting up some sort of hardware, software stack to generate all these sample data sets when tools exist that can just generate it on demand? And there are really 4 main reasons that I could think of that would give a very good reason for this. The first is it's a practical application for software that you may be working with at work, or working with customers, or giving like a real world experience, trying to work with something. It's one thing to go in and look at a Grafana instance that somebody's already set up and be like, yes, okay, very interesting. But to actually go through and set that up yourself, that's a whole different learning experience. When I was a kid, I would always take all my toys apart just to see how they would work. And this is kind of the software version of that, being able to stand everything up from scratch and figure out how it goes. Another reason that you would be interested in doing this is that it's a continuous source of free data for testing purposes. And when I say continuous, I mean typically non-repetitive. If some of the tools that generate sample data, they're kind of stateful. You run it 2, 3, 4 times, and you might have duplicate information. There's only so many random things, unless you get like a truly random data generator. There's only so many John Smiths that you could generate in a data set. However, when you create a system like some of these applications that we're going to be talking about here today, that information is continuously updated and generated on the fly. So it's not something that you're probably going to come across multiple times. Again, it could also provide value to you. Almost every single one of these topics that we're going to be talking about today came about because I was trying to extract extra value out of utilizing them. Trying to be able to get more information or present that information in a more valuable and consistent way that works better for me. And finally, it's a solid use case for home lab equipment. Maybe you have a home lab and you're trying to figure out a way to justify having all that equipment. or maybe you're interested in trying to set up a home lab. All of the things that we're going to be talking about today can be done on very inexpensive hardware and done for very cheaply. And it kind of allows you to get a start with standing up all kinds of hardware devices in your network. So just a quick summary of the things that we're going to be talking about today. We're going to be talking about three main topics, and I hope we'll have time at the very end. If we do, we're going to be talking about a fourth one. So we're going to be talking about weather sensors and airplane tracking. Both of those will have data that's generated wirelessly. And Pi-hole statistics and PA coronavirus information, that information will be generated kind of not RF. It'll be more of a tangible data source that we could look at. So before we get into everything, I realize that not everyone here may be familiar with software-defined radio. So I'm going to give a very quick crash course in what exactly software-defined radio is. In a nutshell, in its most basic distilled lies to children form, there exists this little USB device that was originally made a number of years ago to allow people to plug into their computer and watch television over the air on their computer. Some crafty folks found that if they were to write some different driver software for these devices, they could utilize the Realtek chip that is on the USB device, and that will allow them to tune into any frequency, not just television, any frequency within a certain range, and decode it as they see fit. So what's really interesting about these devices are they're super inexpensive. You can get them from Amazon, you can get them from China, $10, $15 shipped right out the door. And rather than using complicated discrete transistors, resistors, inductors, all kinds of fancy hardware that you would have in a traditional stereo or traditional radio, all of the interpretation is done via software. And kind of at the end of the day, what this means is you can receive any signal between 24 megahertz and 2.1 gigahertz. So there's a very wide range of frequencies. To kind of put that in perspective, you're sitting in your car in your car stereo. You tune the radio on your car stereo. That range is anywhere from about 88 megahertz to 108 megahertz. If you were to imagine that your car stereo could tune higher and lower, there would be a lot more things that you could listen to. You could listen to all sorts of other devices. The two things specifically that we're going to be talking about today wirelessly are the remote temperature sensors, which operate on 433 megahertz. And we're going to be talking about airplane tracking, which is at 1090 megahertz or 1.09 gigahertz. Display is zoomed in on the screen. Sorry, Jay, I'm not quite following what the issue is here. Let me know if it's having a problem. However, the software-defined radio can listen to practically anything. You're only limited by what software you have to actually decode it. The software-defined radio can decode Morse code, broadcast FM, tire pressure sensors, amateur radio, aircraft tracking, locomotive tracking, taxi dispatch, or put another way, planes, trains, automobiles, so on and so forth. So, like I said, you're only really limited by what type of software you use to actually decode the received radio frequencies. Specific to today, what we're going to be talking about is a full open source software stack. The programs specifically for decoding the radio signals, we're going to be looking at a version of Dump 1090, which is an open source program that I've taken and modified for my own use. There's another tool called RTL 433. And we're also going to be looking at this data using Grafana, which is an open source graphing program. And we're going to be using PostGIS, which is an open source database geospatial software. And Postgres itself is an open source database. So I think that covers most of the software side. From the hardware side, however, pretty much everything that we're going to be looking at today is running on Raspberry Pis. I love Raspberry Pis. They're cheap, around $35, sometimes a little more, sometimes a little less. They have adequate resources for the types of things that we're going to be looking at today. They can handle databases of any size with no problem. And since they're typically not all software is packaged for Raspberry Pis, you can also get some good experience with building software from open source and packaging it up for your systems. So, in my case specifically, I will build Postgres from source on a Raspberry Pi. Yes, it's as painful as you think it would be, and deploy it to kind of my cluster. In my data closet right over here, I have these two Raspberry Pis. There's actually a whole bunch in there, but these two Raspberry Pis are the two systems that we're going to be looking at. Yes, that is a Noctua fan on a giant heatsink on a Raspberry Pi. So, without further ado, let's get into it, and we'll talk about weather sensors first. So, weather sensors, for those that are not familiar with them, there's a company called Accurite, and they make, they're probably one of the biggest vendors that provide these wireless temperature sensors. They vary in price. Some of the more generic ones are $30. If you get a fancy one for outside that does wind speed and rain gauge and wind direction and all that, they run about $139. However, the problem I had with these devices was they don't have very good historical data retention. When you get these devices, you get a little base station. I'm going to hold it up here. Let me switch to webcam only. Hopefully I'll get it without a glare, but you'll see it just shows the current wind speed and the peak in the past half hour. You get the current temperature, but it just shows trending up and down. There's not a really good display of kind of how that information has changed over time. The thing is, however, when Accurite is obviously a company that exists to make money, so what they do is they will sell pretty much just a color swapped version of their device and give it internet connectivity and mark it up $100. So, in kind of true hacker spirit, I was like, well, why would I pay an extra $100 when all they're doing is just a software change on the receiving side? I'll just make my own with blackjack and long-term reporting. And so that's what I did. So I wrote a program to receive all that information and store it in the database so that I could look at it as I see fit. To kind of go through the application data flow, we have all these remote sensors all over the place. Like I said, I have one in my data closet. There's one outside in the yard. I have one in the basement that measures the temperature of the freezer. I have one in the garage, all over the place. So all these different remote sensors are sending out their readings, and the RTL SDR will receive that data, and it passes it off to a program called RTL 433. This program is designed specifically for these types of devices, and it will decode the information and pass it off as JSON. Since this was, many, many years ago that I kind of stood up this application, I wasn't really, it was kind of like a proof of concept just to see if I could do it. So I wrote a very quick, very simple Python script to take that JSON data and store it directly into the database. Once it's in the database, I could use a program called Grafana to graph that information and view it over time. So let's hop over to pgadmin, which is a program that allows us to have like a graphical interface on Postgres. And we'll kind of take a look at the actual database side of it. So this is pgadmin, and what we're looking at here right now is my weather database. Apologies if this is going to be a little small. Unfortunately, I can't make the text any bigger because it kind of throws off the way that this application works. However, this application or this database has 3 columns, basically. There's an ID column that just automatically increments for each new item in the database. There's an info column that allows me to store information about a particular reading or a particular time period if I choose to. And then finally, I just have a JSON type column that stores all that JSON information that gets put out from RTL 433. What that actually looks like on the Grafana side is this. So we have kind of a view of the temperature over time, which is notably different than just the individual unit that we just get on the base station. I also have it broken out to show the individual units. I could see the wind speed as it changes over time, outdoor humidity, indoor humidity, and so on and so forth. What's really interesting is this also provides additional information which I can't normally receive with the standard base stations. So, in particular here, I'm talking about signal strength. I like to track the signal strength over time because there's a number of neighbors around here that have solar panels. If you're not familiar, solar panels, when they're in the sun, they tend to be a little bit noisy on the electromagnetic spectrum, so they can cause interference with some certain RF devices. And I could actually see when it gets sunny out, I could actually note the changes in the signal strength and actually see the signal strength dip because it's getting interference between other devices in the neighborhood. It kind of also gives me a little bit of insight into, position of the sensors. I had that sensor in the garage, but since I put that metal box there, now it's causing problems and I can't receive it as well. So it's kind of a nice way to troubleshoot some issues. Another really interesting thing about this is that I can generate reports, monthly reports. And I'll do that at the first of the month and just kind of punch out information about the weather that I've received from all these sensors. So just about 5 days ago, I received this one for the month of November, and you can see the outdoor statistics. So I get kind of like a climatology report. And I could see, the max wind speed in the area, the average temperature, so on and so forth. So it's really interesting and really insightful to see, I had no idea that my garage hit almost 80 degrees in the month of November. It's useful in the summer. Oh, it was over 100 in the garage. Maybe I shouldn't store my beer out there. And so on and so forth. So there's a lot of really useful information that you can kind of glean from this type of reporting. And like I said, it's a very simple setup. So what kind of lessons did I learn from trying to set this up? Like I said, since this was one of the first projects that I really kind of did as kind of like a full project, integrating with Postgres and application side and all that stuff, it wasn't really a major thought in my mind to design the database effectively for long-term use. Originally, it was just meant to be like a proof of concept that I'd throw away, but I actually found out that it was really useful, so I kind of just kept it going. And unfortunately, now the database is trying to keep up with that poor original design. So it's a really good lesson. Yes, exactly, Brett. It's absolutely one of the most important things to set forward, especially if you have the potential to keep using it. Storing data in JSON is okay, it's fine, but it's not nearly as good as native tables in a database. If you think about it, looking here, if I were to go back, and this is an example of some of the data that's stored in the database. So we have our ID, which is kind of just an incrementing number. And all of this information, all these tags for JSON data are duplicated. So tags, the curly brackets, ID, mod, frequency, temperature F, all of that's duplicated every single row. But if it was stored as a native table in the database, that would only be stored once. And then the rest of the values would be stored as a slightly more compressible number. Again, you need really good database design. Having indexes and doing performance tuning on the database is super helpful. And again, since this was a throwaway project, I didn't have a lot of interest in kind of validating data duplication. When it became an ongoing project, this was actually really good data set that I could practice deduplicating information upon. So, again, it's another very useful use case for this data. Not every customer is going to have, not every client that you work with that uses databases will have the best practices set up. So, it's sometimes useful to have a really terrible database that you could practice on and try to recover from. Dig yourself into a hole and try to climb back out of it. So next, let's go on to airplane tracking. This one is really interesting, and it may surprise some folks to know that every airplane that flies overhead is transmitting their location data. It's my understanding that as of the beginning of this past year, January 2020, the FAA required that any aircraft flying in U.S. airspace needs to have what they call an ADS-B transmitter, which stands for Automatic Dependent Surveillance Broadcast. More or less, what this means is the airplanes will send out various messages over radio waves saying, here's where I am, here's my altitude, here's my heading, and other positional information. And that allows like air traffic controllers and other airplanes in the area to kind of all have common knowledge about where everyone is, so that it could help reduce mid-air collisions or track airplanes if, heaven forbid, something happens to them and they crash, so on and so forth. However, what may really surprise folks is the actual number of aircraft that are up in the sky at any given time. I'm using a program here called ADS-B Exchange, which shows it's kind of like a common ingestion site for aircraft. I'm showing here, a good portion of Lancaster County, and there are 11 aircraft currently flying. If I were to zoom out here a little bit and just show the, maybe tri-state area, we're up to almost 1,000 aircraft, and it is almost 2 o'clock on a Saturday. There's an enormous amount of aircraft that are up in the sky at any point. So, this is a really good source for generating data that's very fast. All these aircraft are broadcasting their location. And what I could do is, again, use the RTL SDR to receive that data and use a program that I had taken and modified for my own uses called Dump 1090 that will decode that information and put it out as standard text messages over a UDP socket. Again, I wrote a Postgres Python adapter, which will take that information, dump it into the database, and I could use that database to view all that information. What's really unique is because it's not only like number of messages and things like that, there's also like location data that's associated with it. I could use geography software to visualize all of that information. Let's hop over to the database and we'll take a look at that and see exactly what that means here. So let me shrink this down. Here's ADSB. Here's my ADSB messages database. And there are a number of columns here. I kind of learned my lesson from the first go around. I have everything broken out into their respective columns. And kind of show what that looks like here. We see, a variety of different types of messages. Not all messages contain all types of data. This one just says that the airplane is not on the ground. It's currently flying. You'll notice here that there's latitude and longitude. What's really unique is I could use a query and formulate that with a program called PostgreSQL, which is geography software. And I could query that information, and it will return location objects. So I could actually visualize all of the individual points that an aircraft has said that it was located. If I were to do a little bit more SQL trickery, I could actually format a query in such a way that it will return the actual individual lines that an aircraft has flown. So I could actually see, this aircraft was flying over. Because of my unique location here, I could actually see aircraft taking off from the airport here in Lancaster, taking off and flying out over Lidditz and flying to wherever their destination is. So there's a lot of really interesting data that's here that you could look at. One other thing I want to talk about really quickly here is about views. Views are a Postgres or SQL, generally SQL standard ability that you can create a pseudo table that will reconfigure the way that this data is presented. If you note here, this query is not bad, but it can some of the queries that you might use for this information gets a little terrible. What you could do is you could create views for your database that will allow you to kind of compress all of the various messages that the ADSB transmitters will send out and view them very nicely. So, rather than having to figure out, which columns specifically that I'm interested in, you could create a view called ADSB locations and just do select star on locations, and it'll print out all that data. In fact, that's what I'm using here for these queries. So lessons learned from this. This project I would call baby's first big data. When we're looking at the information collected by these ADSB transmitters, you're receiving upwards of, here's a peak here, over 800 messages a minute of just one particular type of ADSB message. An enormous amount of data here. So, it's a very good practice in how to handle rapid data processing. Believe it or not, yes, a Raspberry Pi will handle passing off 800 messages a minute to a database. It gets a little dicey sometimes, but it certainly will handle it. Like I said about views, you can very easily kind of combine, work on your SQL foo, perhaps, and kind of practice working with views and other kinds of unique database management tools. And data analysis is a really good data set for data analysis. What's really unique here is, maybe since this database tracks the location, it might be interesting to do a query on that location data and see if there are any airplanes that are circling, and then figure out oh, what kind of airplane is circling around Lancaster right now? Is it a government spy drone or something like that? Who knows? It's in the data. You could pull it out, but you'd have to collect it first, and that's what's really unique about this. So enough radio stuff. Maybe you're watching this and you're thinking, I wish I would talk about something more tangible. Let's go into that. Let's talk about Pi-hole statistics. For those who are unaware, Pi-hole is a program that runs, again, on a Raspberry Pi. There's a theme here running. Pi-hole is a program that runs on a Raspberry Pi that will allow you to block ads across your network. You might say, well, okay, I have an ad blocker on my web browser, but you don't have an ad blocker on your PlayStation. You don't have an ad blocker on your phone. This type of device and this type of software will allow you to block ads across every device on your network. It's great. It's awesome. 100% recommend it. But I have some problems as a data nerd with the way that this data is presented. First and foremost, the main dashboard here only shows the past 24 hours. Maybe I don't check this every day. I might check it, once or twice a week and see, what the major hotspot times of the day were. But without kind of going in here and digging through the long-term data and generating extra queries and stuff like that to view it, it's kind of difficult. So in Hacker Spirit, again, I wrote a script that will connect to the Pi-hole's API and scrape all that data and, again, store it in a database. And then from that database, then I could create my own dashboards, which will visualize that information. So let's take a look at what that means. So here, very quickly, let me swap this down here. You can see I'm actually looking at the last 2 days compared to the last 24 hours. What's really unique about this is I have full control over how all this information is presented. You'll notice here on the Pi-hole dashboard, the domains on block list is only showed as a static number. However, since I'm scraping that data over time, I could actually see how the block list changes. So I could actually see, oh, there's a lot of sites, I'm seeing a lot of ads on web pages today. I'm curious what happened. Oh, the actual block list had, reduced by a couple thousand domains. Maybe that's why. I'll go in and look at it. That sort of information is tracked so that you could actually determine, root cause of all that information. In terms of the database, let's hop in and we'll look at that. So I'm going to shrink this down, ADSB. Let's look at Pi-hole. Schemas, Pi-hole, tables. I have two tables here. One is called Pi-hole stats, and that contains a number of columns that are specific to long-term data. So this is stuff like the number of domains on the block list and stuff like that. The other table, however, contains what I call short-term data. This is more or less this information, the stuff that's at a 10-minute interval. I'm not always interested, 6 months from now, I don't care how many DNS requests I had at 2:06 p.m. on December 5th. What I'm curious about is how that has changed over time. So having it in a different table with different rules and different triggers and all kinds of other database management systems, I could actually expire that data and get rid of it when it's no longer useful for me. So this was a really good data set for learning cross-table, cross-schema data handling, having all that stuff stored in different tables. And the information that's gleaned from the Pi-hole API updates over time. So when you're putting it into the database, sometimes it's necessary to do a bulk upsert, which is an insert and an update at the same time. Like I said before, this is really good practice for data retention, making sure that, maybe I'm only interested in the past 6 months worth of DNS requests, expire everything after that. If you're doing a lot of updating and a lot of inserts, your internal Postgres tuning might need some tweaking. So seeing this live, hands-on, gives you an opportunity to figure out how to tune your database to work very performantly, especially on a Raspberry Pi. How are we doing on time here? I think we have until quarter after. Is that right? Yes. So we'll just very quickly hop into Pi-holes or coronavirus statistics. Go ahead, Jay. We have time?
Go ahead. Sorry. I just was going to answer your question about timing. Yes, you have the quarter after.
Okay, very good. Okay, so PA coronavirus information. Before we go into this, I have to disclaim, I'm not a doctor. I'm a computer scientist. I'm not qualified to kind of make any medical assertions based on this data. This is just something that I had found useful to spend my quarantine lockdown time working on. For those who are probably unaware, coronavirus is obviously causing a lot of problems in the world, and particularly here in the United States. And there's a lot of information available for the United States as a whole. But each individual state sometimes has some struggles with presenting data in a timely fashion and providing interpretations of that data. How many new cases per day. A lot of that's just kind of down to an exercise left for the reader. Looking here, this is the Pennsylvania coronavirus information dashboard. They're doing a very good job, the very best they can with the resources that they have. Updating this page, if I were to refresh here, okay, they actually did update it. Very often they don't have the manpower, the human resources to update this information in a timely fashion. For some, it's not uncommon that this page will not have any updates for a day, 2 days, 24, 48, 72 hours. And, as the pandemic continues, it's sometimes important to make that data available so that you can make an informed decision about your life. Overall, however, the information they provide is in this ArcGIS dashboard, which is kind of slow, a little bit clunky, a little bit difficult to use. And throughout the day, it's sometimes difficult to reach this page since there's a lot of folks that are kind of hitting F5 and hammering the server. So I decided to kind of create a database where I store all that information myself, and then I could kind of graph things out and view that myself. So what I did was, again, following the theme here, I wrote some scrapers. I have a Python script that will scrape the Department of Health webpage and load it into the database. And I'm also taking a data set that the New York Times provides regarding per county cases. And I'm also loading that into the database so that I could cross-reference everything. Trust but verify. Always, check your data sources. So once it's in the database, I can do all sorts of data analysis on this. I could print out the number of new cases and make a plot of the new cases over time. I can connect with Grafana and view all that information across the state. So let's take a look at the database side again. So I'm going to switch here to COVID-19 and schemas, COVID-19. I have three tables in this database. One is for the PA specific information. And that just stores information that I'm able to view from the data here. This is the date, the number of confirmed cases, the number of deaths, and then I do some math to, take today's confirmed, subtract from yesterday's confirmed. That's the number of new cases. Growth ratio is, how many cases that is divided by other information, so on and so forth. I have a US-wide table here, and that is that information from the New York Times database. And then I also have a PA events table, which is a separate table that just stores information text-based regarding major events in the process of the pandemic. When were stay-at-home orders issued? When were major public events held? Things like that. And the result being, I could actually go in and view information in a very reasonable way compared to the ArcGIS dashboard. So this is, you get a little teeny tiny new cases per day graph here, but here what I could do is I could scroll down and I could see new cases per day as big as I want, and I could actually select the date range that I'm interested in. So if I'm only interested in the past 31 days, I could see that over time. What's really interesting about this is, since statistics are kind of predictable, you could kind of math doesn't lie. I could actually take the growth ratio, the rate at which these cases are increasing, and make an estimate for the next, for that day. Based on yesterday's number of cases and the rate at which the cases were increasing, I estimate that the cases are going to be X or Y overall. And I could get very, very, very close. In fact, yesterday, the 4th, I was off by a grand total of 10 cases out of, how many? Confirmed PA cases? 411,000. So being off by 10, which is 0.0026% error, it's super impressive. Super impressive that you're able to kind of get this type of granular information generated from here. This is really useful information. So lessons learned from this. This project and data set was a really good lesson in kind of scripting updates. The information provided by the New York Times database is a gigantic CSV file. Being able to create a SQL script that will import it and do all the necessary tools to tune the database for that import is a really good project in and of itself. You can do the data analysis, like I said. Being able to predict the number of cases by only being off by 10 is pretty impressive, and just something that's very easy to do. And like I said, because these files tend to be huge from the New York Times and other data sources, you get really good, hard experience practicing how to import all of that data in a timely fashion. So just wrapping up here, if there are two things that you take away from today's talk, the first is, I hope that you learn that creating your own source of constantly refreshing data is super easy, super inexpensive, and it can provide a really good learning experience, kind of getting into the nitty-gritty details of database administration, software administration, application development, and so on and so forth. And if nothing else, it'll give you a reason to experiment with generating a variety of different data sources, literally from the thin air in some cases, like with the weather station and airplane tracking. So I would love to hear, maybe CPOS 2021, a number of folks that were able to take what I've talked about today and maybe come up with a project of your own. Now I'll be open for any questions. I'm not sure if we had any so far today. while we're waiting for questions, I'm going to post, here are my references. I know there were some questions about making sure that references and links were available, so I'm going to post them here so that they're...
I think I said earlier in the chat that all these sessions are being recorded. We'll publish them after we do a little post-processing and put them up there in the next week or two.